For this video, we are going to be looking at normal and inverse normal distributions. We'll start off with a little bit of notation. So sometimes the questions are written with an x and a little tilde, and this is just read as the variable x is normally distributed with some mean and some standard deviation. So again, n is the normal model, and usually it will say it in the question that data is normally distributed, so you know to use normal or inverse normal distributions. Mu is your population mean, and the standard deviation squared is your variance. So if you want to make a note, this is your standard deviation. First thing we're going to talk about is this idea of a percentile. A percentile is a category to represent part of the data less than a certain value. And a note you want to put to yourself is that this is the area to the left, and that part's going to be important here. So it's always to the left, not the one that's going to be shaded to the right. So first example, for each of the following, identify the percentile being discussed. Sketch the normal curve to show the given percentage. So someone being in the top 10% of your class, you want to notice the location and how much. So our normal model is a bell curve, approximately normal. The middle is going to be represented as mu, which is always our mean. And the top 10% is on that right side tail, and where we can then indicate that this is worth 10%. So we are asked about the percentile being discussed, which we just said was the area to the left. So everything to the left of that shaded 10%, whatever's left over, that would be 90%, which means that this is the 90th percentile. Okay, moving on to another example. Someone who is in the lowest 5% for their height, you can draw a normal curve. We know that the middle is always labeled as mu, or whatever the mean is. Lowest 5% means the tail over on the left. We would label it 5%. And since we already are shaded to the left, this would just be the 5th percentile. All right, so I'm not going to read through all this. You have this in your notes, but basically looking at questions, and you need to determine whether or not it's a normal distribution or an inverse normal question. So I'm just going to highlight some notes for you, and I would suggest that you do the same. Everything on the left has to do with normal. The lengths of 100 pipes have a normal distribution, again it's going to be said in the question, with a mean of 102.4 inches and a standard deviation of 0.2. And they're asking me to find the probability that the pipe lies between 98 and 100 inches. So in this case, in number 1, they're asking to find a probability. Then if we go over to number 2, the marks of 500 candidates in the exam, again, normally distributed with a mean of 55 and a standard deviation of 15. But in this case, they're saying if 5% of the candidates obtain distinction by scoring D marks or more, find the value of D. So the difference over here is that you are given a percent, and you need to find the value. So commit that to memory right now. In one case, it's when you are asked for a percentage, and in the other case, when it's an inverse normal, it's when you're asked to find the value and you're given the percentage. That's kind of a hint as to know which calculation usually you're going to use. So below are your steps for both of them. In both cases, you want to start with drawing a normal curve. So that's what we did above, and you're always going to shade in the direction that you want. Then the part that's different is when you go to use your calculator, You use second vars, which will lead you to the distribution menu. And if you want to use normal CDF, you have your low, your high bounds, your mean, and your standard deviation. If you only have one bound, so if they say like at most something or at least something, you're going to use -1 million for your low and then +1 million for your high. And on the other side, for inverse norm, you need the percentile of the missing value, the mean, and the standard deviation. So in this case, you're only plugging in 3 different values, and we'll do an example together on the next page. So if we want to now solve those questions, we know step 1 says to always sketch our normal curve and label what we need to. So this one tells me that there's a mean of 102.4. And I want to find the probability that it lies between 98 and 100. So we're thinking that 98 and 100, I want to find the probability that I'm going to lie within that range. So it's going to be a normal CDF because they are looking for a probability. And it's going to be your lower bound, your higher bound, your mean, and your standard deviation. So this is normal CDF of 98 to 100, that's my range. 102.4 was my mean, and 2 was my standard deviation. When you plug that into your calculator, you will get 0.1011663227. So a couple things, if you want to note that for yourself, things that are required for these types of questions are your sketch of your normal curve, showing what you're plugging into your calculator, and your final answer. So 3 marks for 3 different steps. Moving on. The marks of 500 candidates in an exam are normally distributed with a mean of 55 and a standard deviation of 15. If 5% of the candidates obtain distinction by scoring D marks or more, find the value of D. So the first thing that's sticking out to me is this is saying D marks or more. This is the top 5%. That or more meant top. And we're going to make a note that you need the percent to the left. That's always the case. You can always use these questions with percent to the left, not percent to the right or above. So my normal curve with a mean of 55. They told me that we're working with the top 5%, so that's where my sketch goes. And I'm looking for this value of D. I know that this is an inverse norm because I was given a percent and I'm looking for a value. The percentile goes to the left, so we'll talk about that 0.95 in a second. We have our mean and our standard deviation. So just make a note here, the reason that we use the 0.95 because you had to use the percent to the left of that value. Plugging that in your calculator, you get 79.7. Moving on to the last type of question we'll look at together. That was a word problem. This one is the same approach mathematically, but they give you information in a different way. So let x be the random variable such that x is normally distributed with a mean of 10 and a standard deviation squared, or a variance of 4. So that's how we read that notation. They want to determine the probability that x lies between 9.1 and 10.3. So they give you your lower bound and your higher bound here. First question we want to ask yourself is it a normal CDF question or an inverse norm? I know that this is going to be a normal CDF, and the reason I know that is because I'm looking for the probability. I have to identify the mean, which is 10, and the standard deviation is going to be the square root of the variance, which means the standard deviation in this case is 2. So for part A, We have our lower bound, our upper bound, our mean, and our standard deviation, which will yield 0.233. So the probability that that x value lands between 9.1 and 10.3 is 0.233. Moving on. Determine the probability that x is less than 10. So this is the only thing where I have an upper bound, but I don't have a lower bound. So I'm still looking for a probability, so it's normal CDF. But I don't have a lower bound, so we're going to use -1,000,000. My upper bound was given, my mean, and my standard deviation, and this will give us 0.5. So at this point, you've seen all the different types of questions. The wording can vary, but your processes will be the same. I'd like you to try the next two for normal and inverse normal distribution.